While we are waiting for our participant to sign in, let us join the pool today to let us know where we are sitting, which continent. You may see a pool on your right or your bottom. And if you just let us know by clicking where you are connecting, that would help us to understand. We can see a lot of participants are checking in. Thank you so much. Our weather is influenced by many climate drivers. El Nino and La Nino have perhaps the strongest influence on year-to-year climate variability. The El Nino Southern Oscillation, or ENSO in short we called, is a naturally occurring global climate change, or global climate cycle. ENSO influences rainfall, temperature, and wind pattern around the world, including New Zealand, where we are actually sitting today. This could influence several or severe hydrometeorological hazards such as drought, flood, storms, fire, many others. Early warning systems is a key for disaster risk reduction. For El Nino, a long-range weather warning, which is available for 30 to 3 months, up to 6 months, and with the advanced science and technology, and also multimodal ensembles, the skills of warning has increased far better from the past, and which has also demonstrated several potential benefit for the society. Tonkin and Taylor, in partnership with Integrated Research for Disaster Risk, Committee on Data, which is called CODATA of the International Science Council of ISC, have brought together today Professor Michael Glantz from Consortium for Capacity Building, University of Colorado, US. You can see Mickey on the left. We have Karif Rafisuna from United Nations Economic and Social Commission for Asia and the Pacific, UNSCAP, sitting from Bangkok, and myself, Bapan Fakhruddin, working from Tonkin and Taylor here in New Zealand. We will be sharing how actually a long-range warning can help communities and our industry to better prepared for severe weather event and the impact of El Nino. Michael Glantz will be sharing with us about the El Nino early warning system, global warming, and communication challenges on El Nino. Karif Rapsuna will be sharing with us how to make El Nino forecast more useful and how countries such as Southeast Asian countries like Indonesia, Philippines, and other countries able to use El Nino long-range forecasting for better applied for their agriculture sector and become the highest rice produced country. And at the last, I'll be telling you how the El Nino has been better applied in Pacific region and how this long-range forecasting can use in our industry, in our society and communities to well prepare us to enhance our capacity as well as ensuring a sustainable society. With these things, I'd like to hand over and welcome Professor Michael Glantz, Director, Consortium for Capacity Building. Michael.
Thank you, Bapan. There are these three issues I'd like to address. And of course, you could probably fill a library now on early warning systems for hydrometeorological events, and especially ENSO or El Nino. Despite the progress that's been made with modeling and with statistical information, there is uncertainty that still surrounds El Nino. And some of that uncertainty makes early warning systems very important. And El Nino's part of the problem is the process of El Nino, which can come either as a weak event, a strong event, or a very strong event. So the impacts are not necessarily the same from one to the other. But what I want to stress in the first point is that El Nino system, early warning systems, are more important than governments realize. So here's a typical image of a society where early warning systems are the apex and society is basically stable. But what happens is early warning systems in this scenario basically is like a searchlight that goes around the base of society and finds a problem and alerts the government and society, fix it. And they go, do it. And the early warning light goes around again, and a year later, oh, fix it. We have hurricanes, tornadoes, cyclones, etc. Things are heavy rains. Fix it. But this is an idealized version, and I personally think it's wrong. I think societies live and survive based on the correctness and accuracy of their early warning systems. And that's why all governments strive to improve early warning systems, even if those early warning systems provide information to the government and not just to civil society, because governments want to know what lies ahead. And so therefore, early warning systems keep them stable. There are governments and city governments, national governments have fallen because their early warning systems on politics or economics or hydrometeorological events fail to warn them. Okay, so this is something very, very important. Now with El Nino, once an El Nino has been forecast, after a while, other sectors of society also create their own forecasts that benefit their particular sector: agriculture, water, energy, humanitarian services that might be required if there are food shortages. Now, we don't necessarily only rely on science. We rely on history. We know now, after 110 or 20 years of being aware of something called El Nino, only now we've got all these cases. How many times have you had droughts in the Philippines because of El Nino, when an El Nino comes, or haze fires in Southeast Asia, or droughts in Northeast Brazil? So we have already a climatology of El Nino. So let's just move on to this. This is droughts, floods, and hunger. This is a map from Oxfam, and at the bottom of this map, it says that El Nino events are supercharging impacts around the globe. That global warming, is supercharging El Nino impacts around the globe. Okay, so the problem is that with global warming, there's a lot of speculation about what global warming is doing to El Nino. Will there be more of them or less? Will they be hitting in the same places or not? What can we say about El Nino? But we have history, so we can use history. And my thing about El Nino serves as a bridge between the present and a climate change future. And the way it does that is the following. If we cannot cope with droughts related to El Nino today, we're not going to be able to cope with droughts that are more severe or in different locations in decades in the future. So it provides us a laboratory every 2 to 7 years. Are we coping correctly? Are we adjusting correctly to a changing climate? Because if the climate's been changing since 1970, at least, say, if it's been warming since then, we're already influencing El Nino's impacts and the El Nino process. And there are some notable changes that have been identified where El Ninos seem to be more now starting in the Central Pacific than along the coast of South America. On this third issue, assuming I have the time, is communicating risk in El Nino. And there, when you have an El Nino warning from an official forecast center somewhere in the globe, all of a sudden there's a cascade of other early warnings. There's early warning 1, I think it's coming. Early warning 2, it's getting closer. Early warning 3, it's stronger. But when is early warning too late to take action? So my view is that we should maybe consider having a late warning system. The reason I say that, some people are risk averse. They want to avoid problems. As soon as they hear El Nino's coming, they start clearing river channels, fixing the land, going to different crop patterns, growing crop seeds, etc. And others are risk takers. Oh, I'll wait till the next warning. Oh, I'll wait till the next warning. until there's a point of no return. And that's when the government can say, sorry, buddy, there's nothing we can do to help you. Okay? And so what we have done is we've done a lot of focusing on lessons learned from El Nino events. But the point I want to make here is that many lessons are identified after every disaster, whatever the disaster is, a flood, a drought, a famine, a locust plague. And society makes a list of lessons. They're identified, but many of those lessons are not applied. They don't have the money, the will, different government changes, etc. And so the same lessons keep reappearing for the same extreme events. And I guess it may be that my time is close to up, but the main thing is that we can be El Nino ready with forecasts, with local knowledge, indigenous knowledge on how they've dealt with previous events. Thank you.
Thank you so much, Mickey, for your talk. That's quite fascinating. Now we'd like to invite Karif Rafisura from UNESCAP, Bangkok.
Thank you very much, Bapon, for having me. Hello, everyone. I'm happy to be with you today, but I have to admit that I'm also immensely intimidated to speak right after Mickey Glantz, who, as many of you know, authored the most influential books on El Nino and society. So in the next 5 minutes, I will share 3 insights into making El Nino warning useful with a focus on public sector experiences in Southeast Asia. I have the fortune of working on disasters and climate-related initiatives in this region, including in an ongoing study on drought being undertaken jointly by ESCAP and ASEAN. So as Bapon noted in the introduction, El Nino plays a dominant role in driving droughts in many places, including in Southeast Asia, and its cold phase, the La Nina, tends to be associated with enhanced rainfall in this region. And because of the strong influence of El Nino and so on the region's seasonal climate, it provides predictability over some locations and seasons. And this is a tremendous opportunity to undertake proactive rather than reactive risk management. So what is usable early warning information? My own view is it really depends on the intended application by users. So for some governments and also some United Nations agencies, El Nino indices, most notably the Oceanic Nino Index, a measure of sea surface temperature anomaly, are sufficient to activate contingency planning and resource mobilization for early response. In recent years, we even see some social protection schemes that use these indices as basis for setting triggers for early interventions, such as cash for work and support for alternative livelihoods. However, other users need information about the expected impact of El Nino on seasonal rainfall or temperature. I'm proud to note that all countries in the region are now issuing seasonal climate outlook 3 to 6 months in advance with monthly updates. The ASEAN Climate Outlook Forum is an important source of peer support that enable countries to produce country-specific forecasts. We've seen successful cases demonstrating the usefulness of seasonal forecast in agriculture and water management. For example, in guiding farm management decisions such as switching crops or changing the timing of planting or even activating supplemental irrigation sources. We also see examples of using seasonal forecasts to anticipate secondary impacts such as forest fires. The success of using ENSO indices and seasonal climate forecasts depends to a large extent on having pre-agreed plans and procedures and how the information would be used, what actions would be taken once certain thresholds are crossed, and where the funds would come from to finance these actions. But on the other hand, other users need seasonal outlook to be further translated into impacts that are of interest to specific sectors or to specific communities. I have to recognize that there's still a lot of scope for improving impact forecasting in this region. In fact, this is still not part of the routine early warning products issued by Met Services or by the relevant sectoral agencies. But my question is, should we wait for all these forecast improvements to take place before applying El Nino early warning? What do you think? So I would argue that taking action in known vulnerability hotspots is good development despite forecast limitations. As Mickey Glantz mentioned earlier, we can rely on history. So based on the impacts of past El Nino events, we already have some knowledge of the places that are sensitive even to the slightest rainfall deviations because of high poverty levels, persistent food insecurity and malnutrition, and dependence on subsistence farming as the source of livelihood. So the slide here shows the hotspots during the drought peak in 2015. And many of these locations would be the same for other El Nino events. But new hotspots could also emerge. For example, communities where the expected impacts of El Nino would interact with ongoing disaster impacts would definitely be areas of concern. So learning from the work of Red Cross societies and some United Nations agencies in this area, what appears critical is putting in place procedures for receiving updated forecast information and adjusting actions and resources as the forecast becomes more certain. As Miki said earlier, you need early warning, but you also need late warning to adjust your strategies on the ground. And finally, establishing predictable mechanisms for communicating information to a whole range of decision makers, from policymakers to farmers, is essential. Several Met services in the region are now convening regular monsoon forums ahead of each season to explain their seasonal climate forecast to users and to obtain feedback. The regularity here is essential. The users need to know when to expect the release of critical information for climate-sensitive decisions. In many countries, government agencies and non-governmental organizations collaborate in running climate field schools to empower farmers to interpret and use climate information. We've also seen innovations in delivering integrated agromet services to farmers through mobile-based applications. So let me conclude by highlighting that although the El Nino is the strongest influence on the region's seasonal climate, it's really not the only one that we are worried about. The recent droughts in the region reinforce for us that strong droughts are possible even during a weak El Nino or even without it. And people do not experience the impacts of different climate drivers in isolation. For example, if your entire cropping season fails, you don't care very much, whether it's because of the El Nino or the Indian Ocean dipole or anthropogenic climate change. So overall, I think what would be useful is to upgrade our disaster and climate plans to manage concurrent disaster risk and their compounding impacts. So thank you very much for listening. I look forward to your feedback.
Thank you so much, Garif. You actually makes my slide quite easy. So if we just now look back or some reflection from Kiglans and Garif's talks that, and also looking at the dimension of climate forecasting, the hazard itself, time horizon, and also the confidence levels. Obviously, there is always a misbalance we will see between the user expectation versus what we can actually provide as a forecaster or a Met service in our own community. On the left slide, you can see that science has a particular skills which can provide up to a certain limit, but whereas as a user, we always actually demand more, and our expectation is quite high. And when there is a mismatch, there is a expectation doesn't meet, we doesn't actually want to utilize those information accurately, or we doesn't want to internalize those information in our decision-making process. So how actually we can balance those things is quite important. One of the examples Garif just shown that how Met Service actually put forward to bringing some of those climate forum or monsoon forum to interact with the user to better understand, better provide guidance at how the season look like, and how to also understand what is their expectation from them. But the more actually the warning system increased, the more uncertainty it begins. But even though there is actually usability of such information, especially on the sectoral or strategic decision making. So a 3 to 6 months forecast, which we are actually talking about a long range forecast or long range warning, it doesn't need to have a application immediately because you have actually time horizon to making your decision, your strategic decision into a tactical decision making, so that it can plan you better for your application. And having a seamless warning system, so you have actually short range, medium range, and long range forecasting. So having a seamless integration of all these things could able to provide you a better decision making process. It has been applied in many countries, the long range warning systems, using several kind of tools. Some country they call it drought index, somewhere they call it, in the Caribbean they call it like a Galvez deviation index, or in the Africa they call it convective potential index. So how this index actually built up using multiple phenomena, climate driver, that is quite important. And the question would be actually whether actually this has a used, or does this actually able to provide you sufficient information to making your decision within the for the season, or within for your planning process. In a short answer could be yes, because there has been a lot of example we saw in the last mega El Nino event that happened in 2015 2016, and what we have learned from 1917 and 1918. So that gives us a quite good example from 1917, 1918 to apply in 2015, 2016, especially in the Caribbean, in the Pacific, in the Micronesian area, as well as in the African country. And you may also see some of the examples that has been applied in recently in our neighbor country in Australia. They actually started providing this week-to-week basis, a seasonal forecasting system up to 3 months to 4 months, and different sector actually able to utilizing the information for their differential decision making process. But obviously there is a complexity, but question would be how actually we better use our all this advanced science, or how actually we use the multimodal ensemble to making trigger a right information for us. So if you look at on a particular hazard that we are talking a little bit today on drought early warning systems, and also Karif just mentioned that El Nino or ENSO is not only the only driver that actually play on the drought or even for the flooding in a seasonal basis. There are, when you come to a microclimatic season or microclimatic environment, there are actually many systems work. So you have an ENSO, you have a sea surface temperature anomalies, you have a southern oscillation, you have a Pacific decadal oscillation, Antarctic oscillation, so many things. So how actually we better understand all these climate phenomena, and how actually we better integrate those things into our decision making, that is quite important. Because if you just only depend on ENSO or El Nino, that may not able to give you a quite good or accurate result within a one when you are in a very small zonation area. And also a overall system need to be quite integrated, because um, as an early warning system, so it is actually a system of a system. So if you don't look at in a system-based thinking, it's quite hard to understand how the overall systems will be working. So it maybe you start with your historical observation or your history on the past, to lessons that you have learned, that how the history in that particular area that you are dealing, the climate actually behaving. And based on the history, you can actually relate with your prediction or providing using a seasonal climate outlook. And using this climate outlook, regional climate outlook, you can actually interpret into a local climate outlook, or into transform into a hazard outlook, what could be happening within the particular season, or which has a tendency to increase or decrease. And using your exposure in the area, as well as your vulnerability from historical database or historical disaster loss database, you can easily interpret or translate that hazard into a risk for that particular area. And then the question would be how actually we engage our partners, our sectors, our policymakers to better making a decision, or developing a better decision support systems to interpreting the risk into action, and then how those actually action or the plan that we can develop that could actually mitigate our consequences that going to be happen based on the driver, or the most of these climate drivers. But again, if you look at the seasonal forecast, which has been applied in many fields, such as drought early warning systems, it able to quite well used for your seasonal hurricane or cyclone behavior understanding, or cyclone number of probability of cyclone happening, which is quite good actually reflection we saw in Pacific in 2020 this year. It also used for reservoir operation, how actually you can actually manage your water storage and demand and supply management, which is quite strongly used in African countries as well as in Southeast Asia. The dairy and to understand your dairy or livestock production and market forecasting, it has been also quite used globally by several other countries like Brazil, China, US. There has been also utilization of ecological restoration forecasting model using seasonal climate forecast. Wind farm also used quite heavily, rely on this seasonal forecasting. And there is also a lot of epidemics like dengue fever forecasting is applied. But one of the things we need to be understand here is that when you're actually looking at a seasonal forecasting systems or seasonal warning systems, it's only applicable actually on slow onset disaster perspectives or slow onset hazard perspectives. But again, when you are dealing with a slow onset hazard, there are a lot of things need to be made, decision need to be made through the policymakers, because there is a huge engagement with the policymakers or decision makers on this warning into action. And here comes a quite strong bindings or relationship need to be established between the policymakers, how actually you convince using a science, because none of the policymakers usually accept a uncertainty or a probability information. They like more deterministic information. They like more certain information so that they are able to confirm to their people. But how actually a probabilistic information or a little bit uncertain information could be developed using could develop a consequences forecasting is quite important to having a strong institutional relationship with policymaker versus the provider. And that only can actually able to trigger your action into a consequences. Overall, finally, I just like to say that obviously each of the country or each of the UN member states are bindings to 4 major global frameworks that need to be achieved by 2030. We are already in 2020. We have almost 10 more years left over, and early warning system has been defined as one of the core important part to disaster risk reduction or achieving this 4 framework, which is Sendai framework, Sustainable Development Goal, Paris Agreement, as well as UN Habitat. But when you're looking at the system-based forecasting or system-based thinking, it's actually quite complex. On the right side, you can see a 4-dimensional systems. You're actually looking for from hour to century lead time information. And on the other side, you're actually looking, the information needs to be connecting from global to the local. But at the same time, so you need to be understanding how this information actually transform into your hazard and how that could be exposed and vulnerability of the society. And then how actually cascadingly it actually impacting your overall sectors from infrastructure, ecological, economics, human, and political dimension. So having this integration is quite complex and difficult. But the reality is using a useful and usable information, industry sector and community were able to understand the foreseeable risk, and they can actually able to utilize those things for their future adaptation option. With these things, I just like to finish my talk, but the floor is open for question. Feel free to put your question on the chat box. We'll be able to answer you. Thank you so much. I have received a couple of questions already. So may I invite all the speakers to coming back online. There is one question that has been asked by participant. How does the recent erratic climate pattern affect effective long-range early warning systems? Anyone like to answer these things?
We talk about El Nino in the Central Pacific, but as you mentioned earlier, and it's identified, there are oscillations in the atmosphere all over the place, around the globe. And some are strong, some are weak, highs, lows move. And what happens is it affects El Nino. In terms of El Nino is not the only game in town, it's just an important one. And it's like the seasons. Many societies don't even get ready for their season change, let alone for El Nino change. And while, just to address a couple quick things, some societies can't afford to prepare for El Nino. They know it's coming. They have no money. They have no help. They have no science to back up what they want to do. So what they do is they choose to wait until the forecast is definite, and they take tactical responses. They get ready for the event. So a lot of the difficulty is in that period of when there's a forecast, but it's uncertain, and when that forecast uncertainty is gone and it becomes real. So governments can't be blamed when they're playing the odds, just like farmers do without these elaborate forecasts. I don't know if that answers the question, but I wanted to say it.
Thanks, Mickey. There is a question for Karif. Does Sesame is password protected? Can you please describe its functionality when you get the change in discussion session?
Yes, I sent a private reply to Adele. It's basically a tool for delivering weather and climate information to district level. And the idea is to further evolve this app. It's an app in order to incorporate other types of information in addition to weather and climate. As I think both speakers noted in the discussion, it's not really only weather and climate information that decision makers need in order to make critical decisions to avoid adverse impacts. You also need other information. So in the context of agriculture, for example, you also need market information or information about the supply chain. So I think, Adele, I'll send you more detailed information by email.
Thanks, Karif. One more question for Mickey from Jafar Adel. Could one argue that the real problem is triggering current action by engaging the pertinent actor, say the government, rather than providing an early or late warning? Mickey, you are mute.
Can you repeat the question one more time? I didn't quite understand.
So could one argue that the real problem is triggering current action, say the government, rather than providing an early or late warning?
You need early warnings. Okay, I'm not a scientist. I'm a social scientist, worked with science for decades. But we need science. Okay, even with its uncertainties, we have history plus uncertainties. We're learning all the time. El Nino was only discovered as a global, worldwide phenomenon in 1969. So we've been it's a relatively new topic. So I think we shouldn't be blaming El Nino for all of the bad things that happen during an event, but we shouldn't blame the government for all the bad things that happen either. It's understandable that they're humans. They want some certainty, and they wait and they wait, and and things happen while they're waiting. Even with a weak El Nino, they may do nothing, but a weak El Nino, as Karef said, that you can have major damage. So you have to work. It's like left hand, right hand. If you only use El Nino stuff, you're like clapping with one hand, no noise. You need decision making, society, farmers. Everyone has to be in this mix.
Thanks, Mickey. So we will take two more questions, and then we need to ending our session. So maybe the one question we like to ask here is: would cities and large communities have their own early warning systems and response planning in addition to national government plan? I may just answer a little, and then maybe Karif could join on the plan. So obviously, I would recommend that you have your own national hydrometeorological services, and they are quite good enough to providing the long range early or long range warning system. You don't need to have a separate early warning system for your cities or your small communities. But for the planning, obviously, yes, you should have your own plan, community-based plan, aligned with your regional versus national plan. Karif, do you like to add anything on the plan?
Sure. Thank you, Bapon. I agree with Bapon, and it's very important for each jurisdiction actually to have its own plan because the impact of El Nino on climate is or tend to be very specific. So, for example, in the Philippines, where I'm from, there are four types of climate, and each climate type responds to El Nino signal differently depending on the season or depending on the ENSO onset. And the second reason for having your own national plan is, I think, related to the question earlier. How do we trigger actions? So each plan should have a pre-agreed threshold. When do we start releasing money to undertake these actions? When do we do the first early action in order to prevent early damage, prevent damages? So I think these decisions are very specific to specific jurisdictions. So it's very important to have your own plan in addition to the overall national plan.
Thanks, Karif. We'll be ending with this last questions that has been asked. What has been used before El Nino long-range warning systems, and why have we not used this before? Anyone like to answer? You're
Well,
mute. Yep.
as
Go ahead.
as far as I recall, that before El Nino forecasts, I mean, we had forecasts about seasonal changes, winter storm, within the seasons. We've had forecasts. The thing is that what they did before was to have patterns of interaction. So they would see the highs and lows in a particular region, and they would develop types of these arrangements of highs and lows and sea surface temperatures, etc. And they would then say, "Oh, this season it looks like this pattern is coming to pass." So we've been doing longer range forecasting. Like even a local forecast now we're pushing out to 2 weeks. We're starting to see 2 week forecasts. So they're trying to join the 2 week forecasts, the shorter term forecasts, with the longer ones, which are season and beyond. Okay, so El Nino is after the seasonal flow, the biggest disruptor of human activities is El Nino. Okay, how well do we get ready for the seasons? Some do, some don't, and so and for El Nino, some will and some won't.
Thanks a lot, Mickey. And I think if you look at the whole El Nino talking or El Nino warning system, it's not actually so long. I mean, it's probably started with 1980s when we have actually super El Nino. We called it 1982, and then again we faced actually 1997, and then several actually donor agencies like USAID, UK Aid, they have actually triggered so many good programs in the region, and that shows some benefit and some useful information that people could utilize, especially on the agriculture sector or the water management in the Africa, where actually water has a quite scarcity, and that actually lead us now today with this 20th century in 2015 again a big El Nino, and how actually the question is actually whether we are actually using potentially the science information that available with us. There are so many advancement on science using forecasting technology, but how much actually we are utilizing those information and how much actually underutilized just in the research fields, how many of those research actually coming to our operational domain, and how much of this operational domain information actually translating to the community to making a decision. That is quite important at this stage. And using this advanced information science technology, we believe that there is a potential usability and usefulness, and using these things it could actually really help our society to better enhance their capacity and industry to making that decision and progress. With these things, we thank you everyone. We can see that each of the continent actually joining with us today for this session. And thank you so much for many of you who are actually joining from Africa or Europe. It's just a quite late night there, and we really appreciate your time to listening to us. We look forward to joining with you several other series of early warning systems. Today we talked about long range. Next time we'll be talking about mid range, and then following by we'll be talking about short range weather forecast using different expertise and expert throughout the globes. Thanks again for your time. Bye bye.